Evaluate this integral where the circle C is mod z equal to 1. We are going to do this example with the residue theorem. So this is the function given to us. So let's find the simple poles first. What poles we are getting? By taking this denominator equal to 0, we get cos of pi z equal to 0. That means where cos is 0, it is 0 at cos of 2n plus 1 pi by 2, right? Where this n is belonging to the set of integers, so that means we are getting pi z to be equal to 2n plus 1 pi by 2. So these two cancelled out and we get z to be equal to 2n plus 1 divided by 2. When putting n equal to 0, we get z equal to 1 by 2. But I am writing here plus minus sign because n is belonging to the set of integers. And now putting n equal to 1 over here, we get 3 divided by 2. But here plus minus sign because n is also 1 and negative 1, the set of integers. Similarly, the next value would be putting n equal to 2, we get plus minus 5 divided by 2, so on. And from these points, which points lies inside the given circle mod z equal to 1? Only plus minus 1/2 lies inside the circle mod z equal to 1. All others are lying outside the circle, right? So we are going to calculate the residue at these 2 points only. So finding the residue of fz at first z equal to 1 by 2. What is the formula for that? It is limit z tending to 1 by 2 and writing here z minus this point f of z. So this is equal to limit z tending to 1/2 and it is z minus 1/2, writing here fz, that is e the power z divided by cos pi z. So this is e the power z divided by cos of pi z. So when I put z equal to 1/2 over here, I am getting the numerator to be 0 and also denominator is 0. It is a 0 by 0 form. So we need to use the L'Hopital's rule over here. Derivating the numerator with respect to z, we get first function derivative of second plus second function derivative of first divided by derivating the denominator with respect to z minus sine pi z into pi, right? And now when I put z equal to 1/2 in this, I get the first term is 0 plus second is e the power 1/2 divided by minus pi into sine of pi by 2, right? So sine of pi by 2 is 1. So we get this to be minus e the power 1/2 divided by pi, right? So this is a residue at z equal to 1/2. Similarly, we can find the residue at the point z equal to minus 1/2 and that is equal to, you just calculate this, you get this to be e the power minus 1/2 divided by pi, right? So now we are going to use the residue theorem. So by residue theorem, the given integral, that is e the power z divided by cos of pi z dz is equal to, the formula is 2 pi iota into the sum of the residues we have calculated. So this is equal to 2 pi iota. Okay, what is the first residue we have calculated at z equal to 1/2? This is minus e the power 1/2 divided by pi plus the second residue is this e the power minus 1/2 divided by pi. If I take minus outside, I will be getting minus 2 pi iota into e the power 1/2 minus e the power minus 1/2 divided by pi, right? So this pi is cancelled out with this one. Let me write this again. So we have got minus 2 iota into e the power 1/2 minus e the power minus 1/2, right? And if I multiply and divide by 2, then this becomes the formula for the sine hyperbolic 1 by 2. You can also leave the answer as it is, but the another way to write the answer is also, this is minus 4 iota sine hyperbolic 1 by 2. So this is how we have solved this integral. Okay, thank you. Stay blessed.